July 10th, 1913. A weather station in a remote California valley recorded a temperature of 134 degrees Fahrenheit, 56.7 degrees Celsius. That number has never been matched anywhere on Earth in the 113 years since. To put it in physical terms, at that temperature, you can fry an egg on the pavement in minutes. Metal surfaces become too hot to touch with bare hands. The air itself feels like opening an oven door directly into your face. Except there is no door to close, and it just keeps going. Death Valley sits below sea level, 282 feet below at its lowest point. It is surrounded on all sides by mountain ranges that trap heat the way a bowl traps water. The sun hammers the valley floor for up to 14 hours a day during summer. The ground absorbs that heat and radiates it back upward, creating a feedback loop that turns the air above into something that barely resembles what the rest of us breathe. In summer, the average high temperature here is approximately 115 degrees. Not the record, the average. And yet, somehow, Death Valley is one of the most visited national parks in the United States. Every year, roughly 1 million people drive in. They get out of their cars. They take photos. They walk around. Some of them don't make it back. This is Death Valley, the hottest place on Earth, the lowest point in North America, a landscape so extreme it has killed experienced hikers, stranded motorists, and seasoned adventurers who thought they knew what they were getting into. And it is one of the most beautiful places on this planet. This is the story of how that's possible. The name was not chosen lightly. In the winter of 1849, a group of emigrants crossed this valley on their way to the California gold rush. The crossing nearly killed them. When they finally escaped through a mountain pass and looked back at the valley below, one of them reportedly said, "Goodbye, Death Valley." The name stuck, and over 170 years later, nothing about it feels like an exaggeration. To understand why Death Valley exists, you have to understand what's happening to the ground beneath your feet across the entire American West. The Basin and Range Province, a geological region that covers much of Nevada, Utah, Arizona, and Eastern California, is slowly being pulled apart. The Earth's crust here is stretching, thinning, fracturing along fault lines that run roughly north to south. As the crust breaks, some blocks of rock drop downward while others are pushed up. The blocks that drop become basins. The blocks that rise become mountain ranges. Death Valley is the most extreme example of this process on the continent. The valley floor sits approximately 282 feet below sea level, the lowest point in all of North America. The mountains directly to the west, the Panamint Range, rise to over 11,000 feet. That means within a horizontal distance of roughly 15 miles, the landscape goes from the lowest point on the continent to peaks higher than most mountains in the eastern United States. The vertical drop is nearly 2 miles, and it happened because the ground fell. But Death Valley wasn't always like this. Approximately 20,000 years ago, during the last ice age, this entire valley was filled with a lake. Not a shallow puddle, a lake up to 600 feet deep, stretching nearly 100 miles from end to end. Glaciers melting in the mountains sent rivers of water cascading into the basin faster than it could evaporate. Scientists call it Lake Manly. It is completely gone now. What it left behind are the salt flats that cover much of the valley floor today, the accumulated minerals of a lake that dried out over thousands of years, crystallizing into the white hexagonal patterns that make parts of Death Valley look more like an alien landscape than anything on Earth. The mountains that surround the valley on all sides do something else besides creating extraordinary scenery. They trap heat. Air flowing into the valley from above sinks as it descends, and as air sinks, it compresses and warms. The mountains block that air from escaping. The valley floor absorbs heat from the sun and radiates it back upward. The result is a system where heat enters from multiple directions simultaneously and has almost nowhere to go. It is, in the most literal sense, a natural oven. And unlike the oven in your kitchen, it runs 24 hours a day, 7 days a week, for months at a time. The record of 134 degrees wasn't a fluke or an anomaly. It was Death Valley doing exactly what Death Valley does.
Heat behaves differently here. Not because the laws of physics change when you cross into Death Valley, but because this place has assembled every possible condition for generating and trapping heat, simultaneously, continuously, without relief, in a way that exists nowhere else on the planet. Start with the geography. Death Valley sits at the bottom of a basin surrounded on all sides by mountain ranges. When air flows in from the surrounding desert, it has nowhere to go but down. As air descends, it compresses. As it compresses, it heats up. By the time that air reaches the valley floor, it is already warmer than when it started. Then the ground takes over. The valley floor is covered largely in dark rock and gravel, surfaces that absorb solar radiation efficiently and hold it long after the sun moves on. On a summer afternoon, ground temperatures in Death Valley can reach 201 degrees Fahrenheit, 72 degrees hotter than the air above it. That superheated ground then radiates its stored heat back upward, warming the air from below, while the sun continues warming it from above. Heat enters from multiple directions at once. But the most counterintuitive part of the Death Valley heat equation isn't the desert floor or the sun. It's the mountains. Those same mountain ranges that trap the descending air also block the wind. In most places, wind provides evaporative cooling, the mechanism that makes a hot day feel survivable if there's a breeze. Death Valley's surrounding peaks act as a barrier, leaving the valley floor almost completely still for extended periods. No wind, no evaporative cooling, just heat layering on top of heat with nothing to interrupt it. The humidity, or the near total absence of it, completes the picture. Humidity slows the rate at which your body loses heat.
In a humid environment, sweat doesn't evaporate quickly, which means your body's cooling system becomes less efficient. Death Valley is one of the driest places in North America, sometimes recording humidity levels below 5%. That sounds like it would help. It doesn't. At extreme temperatures, low humidity means your sweat evaporates so fast you don't feel it, which creates the dangerous illusion that you're not sweating heavily. People have died in Death Valley convinced they were fine, minutes before their core temperature became incompatible with life. The human body begins to struggle when the air temperature exceeds its own core temperature of 98.6 degrees Fahrenheit. In Death Valley during summer, average afternoon temperatures exceed 115 degrees. At that point, the body can no longer cool itself by releasing heat into the surrounding air, because the surrounding air is hotter than the body itself. The direction of heat transfer reverses. Instead of your body releasing heat outward, the environment begins pushing heat inward. The only thing standing between you and hypothermia is how fast your body can sweat and how much water you have left to sweat with. Which is why the National Park Service's advice for visiting Death Valley in summer is unusually blunt for a government agency. Stay in your air-conditioned car. Do not hike. Drink a liter of water per hour. Know that if your car breaks down on a remote road in July, you may have hours, not days. This isn't caution for its own sake. It's a calculation based on how many people have ignored it and didn't come back. And yet, every summer, they come. 1 million visitors a year. Many of them in July and August, when the valley is at its most extreme. Some of them specifically because of the heat, chasing the record, wanting to say they stood in the hottest place on Earth at its hottest. Death Valley has become, improbably, a destination for people who want to test what they're made of, against a place that genuinely does not care whether they survive. The valley doesn't offer second chances. It just keeps doing what it has always done.
Walk far enough into Death Valley and you start to notice something. Tracks in the sand, a lizard disappearing under a rock, a raven circling overhead in air that would ground most birds. Life everywhere, in a place whose name suggests the opposite. The valley floor gets the most attention. The salt flats, the heat, the record temperatures. But the ecosystems of Death Valley are vertical as much as they are horizontal. The same park that records the hottest surface temperatures on Earth also contains peaks above 10,000 feet where snow falls in winter and pine trees grow at the summit. Within the boundaries of a single national park, you can stand in the lowest, hottest place in North America and look up at mountains that receive more annual precipitation than Seattle. Death Valley isn't one extreme environment. It's several of them stacked on top of each other. At the bottom, where survival seems most impossible, the desert kit fox has been perfecting its adaptation for thousands of years. It hunts at night, never during the day. Its enormous ears are not just for hearing prey, they're radiators. Blood flows through the thin skin of those ears and releases heat into the cooler night air, allowing the fox to regulate its body temperature
without wasting the water it can't afford to lose. Every feature of every animal here is a solution to a problem that would kill something less perfectly adapted. The most extreme example isn't the largest animal in the valley, it's the smallest. Devil's Hole is a geothermal pool in the Nevada section of Death Valley National Park, a crack in the earth that drops into an underground aquifer connected to a water system that extends for miles beneath the desert. The water temperature holds at approximately 93 degrees Fahrenheit year-round. The oxygen levels are so low that most fish would suffocate within minutes of entering. Living in this water, and nowhere else on Earth, is the Devil's Hole pupfish, a fish roughly the size of your thumb, silver blue with iridescent scales. Estimated population, somewhere between 200 and 260 individuals in total. Not 200,000, not 200 million, 200. The entire species exists in a single pool, in a single crack in the ground, in the middle of one of the harshest deserts on the planet. It has been isolated there for somewhere between 10,000 and 20,000 years, since the last ice age, when the aquifer systems of the Great Basin were connected and fish could move freely between them. When those connections dried up, the pupfish that happened to be in Devil's Hole stayed there and adapted. Then there is the Superbloom. Every few years, not every year, not on any predictable schedule, Death Valley does something that makes international headlines. After an unusually wet winter, the desert floor erupts. Seeds that have been lying dormant in the soil for years, sometimes decades, germinate simultaneously. Within days, a landscape that looked like the surface of Mars is covered in wildflowers. Purple phacelia, yellow desert sunflowers, white evening primrose, color stretching from one end of the valley to the other in a display that lasts only a few weeks before the heat reclaims everything. The seeds don't germinate every wet winter. They wait for exactly the right combination of moisture, timing, and temperature, a threshold the desert has been calibrating for millions of years. Too little rain, and they stay dormant. Too much, too fast, and they rot before they can root. When the conditions are exactly right, the desert remembers it was once something else. What Death Valley teaches about life isn't that it's fragile. The pupfish in its 93-degree pool, the kit fox sleeping underground through the hottest hours of the day, the seeds waiting years for a single wet winter that may or may not arrive. None of them are surviving here by accident. They are the result of millions of years of pressure selecting for exactly the traits that work in this specific, extreme, unforgiving place. Life doesn't just tolerate Death Valley. In its own way, it has made it home.
Long before anyone called it Death Valley, people lived here. The Timbisha Shoshone have inhabited this landscape for over 1,000 years, not passing through, not surviving temporarily, but living here as a permanent home across dozens of generations. They called it Tumpisa, the place of the rock paint, and they knew it in a way that no outsider has ever fully replicated. Which springs ran in which seasons, which plants held water, which routes through the mountains stayed passable when the valley floor became lethal.
They moved with the seasons. Summer in the mountains, where temperatures were survivable. Winter in the valley, where the climate was mild enough for permanent camps. They didn't conquer Death Valley. They learned to read it. That knowledge, accumulated over a millennium, was almost entirely disregarded when a group of lost emigrants stumbled into the valley in December of 1849 on their way to the California gold rush. They were trying to find a shortcut to the gold fields. They found the opposite. For nearly a month, different factions of the group wandered separately through the valley, watching their oxen die, burning their wagons for warmth during cold desert nights, eating whatever they could find. One man died. When the survivors finally escaped through the Panamint Mountains and looked back at the valley below, it received its name. Goodbye, Death Valley. The gold rush brought more people. Then silver and borax mining brought permanent settlements, towns that sprang up almost overnight around mineral deposits and disappeared just as fast when the deposits ran dry. The ghost towns that remain, scattered across the park, are the evidence of what happens when people try to impose permanence on a place that doesn't offer it. Rhyolite, Skidoo, Ballarat. Names that once meant something. Stores, saloons, post offices, thousands of people. Now reduced to foundations and crumbling walls in the desert. Death Valley kept doing what Death Valley does. And eventually, everyone left. Today, the Timbisha Shoshone are still here. In 2000, after decades of advocacy, the tribe received formal recognition of their ancestral homeland. 7,400 acres within the national park, where they have the right to live permanently. They are the only Native American tribe with a resident community inside a national park in the United States. They outlasted the miners. They outlasted the ghost towns. They outlasted every wave of people who came to Death Valley convinced they could master it. The modern visitors are different only in their equipment. Air-conditioned cars instead of ox-drawn wagons. GPS instead of guesswork. Energy drinks instead of whatever the emigrants could scavenge. And yet, every single summer, people die in Death Valley for reasons that haven't changed in 170 years. They underestimate it. The typical scenario documented by park rangers follows a pattern that has become almost routine. A visitor arrives in July. They decide to hike a trail that looks manageable on a map. 2 miles, 3 miles, nothing that would challenge them back home. They bring a single water bottle. They set out at 10 in the morning when the temperature is already above 100 degrees and climbing. What they don't account for is the physics. At 115 degrees, your body loses water through sweat faster than most people can drink it. A single litre disappears in less than an hour of hiking. And unlike other forms of physical distress, severe heat stroke doesn't always announce itself clearly. Confusion, poor judgment, a feeling that things are actually getting better. These are symptoms, not signs of recovery. People have been found dead within sight of their cars, within a quarter-mile of shade, within minutes of what might have saved them. The National Park Service has stopped counting how many times they've rescued people who started a hike with the words, "I'll be fine, it's only a short walk." Death Valley has never once agreed with that assessment. It doesn't argue with you, it just waits. Something is shifting in Death Valley. Not metaphorically, measurably, in ways that the instruments placed across the valley floor are recording with increasing frequency, and that the rangers who have spent careers here are noticing in ways that don't show up in any database. The records are falling. Not the all-time record of 134 degrees, that still stands from 1913, but the records for sustained heat, for consecutive days above 120, for overnight low temperatures that no longer drop enough to give the desert the recovery time it has always depended on. In July of 2021, Death Valley recorded an overnight low of 107 degrees Fahrenheit. 107 at night, after dark, when the desert is supposed to cool. It was the hottest reliably recorded nighttime temperature in human history. The flash floods are coming more often. Death Valley receives less than 2 inches of rain per year on average, but when rain does come, increasingly in intense bursts rather than gradual accumulation, the consequences are extreme. The desert floor, baked into near impermeable hardpan, can't absorb water fast enough. It runs off immediately, channeling into the canyons and washing across roads with a force that carries boulders and strips asphalt as if it were paper. In August 2022, a single storm dropped more than 3/4 of the valley's annual average rainfall in a matter of hours. Roads closed. Visitors were stranded for days. The park looked, briefly, like something from a different planet. Then the water evaporated. The salt flats dried. The heat returned. And Death Valley went back to being Death Valley. There is something almost defiant about that. Every system we've built around this place, the visitor centers, the paved roads, the campgrounds, the carefully managed trails, exists at the tolerance of a landscape that was here millions of years before any of it, and will be here millions of years after. The Timbisha Shoshone understood this. They built their relationship with the valley around what it allowed, not what they wanted from it. The miners who came after didn't, and the ghost towns are their legacy. The question for everyone who comes now, the 1 million visitors a year, the scientists, the park service, the people making decisions about what gets built and what gets protected, is which of those two approaches makes more sense going forward. Death Valley became a national monument in 1933, a national park in 1994. Those designations didn't protect it from change. Nothing protects a landscape from change, not permanently, not on the timescale that matters to geology. But they protected it from the kind of change that comes from treating a place as a resource to be extracted rather than a system to be understood. And that distinction between extraction and understanding might be the most important thing Death Valley has to teach. Standing in the valley at dawn, before the heat builds, before the tour buses arrive, before the temperature crosses 100, there is a stillness here that is unlike anything else on Earth. Not peaceful exactly. The silence is too complete for peaceful, too empty. The kind of silence that makes you aware of your own heartbeat and your own breathing in a way that a quieter place somehow doesn't. It is the silence of a place that has never needed us, that was here before us, that will be here long after the last road has crumbled and the last sign has rusted away, and the valley floor has reclaimed everything we thought we built to last. Death Valley is just one of them. All over this planet, there are places that operate outside the rules we think govern how the world works. Places that are older than our languages, more patient than our civilizations, more extreme than anything our bodies were designed to handle. We find a new one every week. If you want to be there when we do, subscribe. New documentary every week. And before you go, we want to hear from you. Death Valley has been called the most inhospitable place in America. But if you could spend one day there, the salt flats at sunrise, the sand dunes at golden hour, the canyon in a flash flood, the night sky with no light pollution for 100 miles in every direction, which would you choose? Drop it in the comments. Every single one gets read. Thanks for watching.